Alhamdulillah, wassalatu wassalamu ala rasulillah. We are in section 4.2, and this is objective 5, how to graph logarithmic functions. We studied exponential functions in 4.1, and this is the graph in blue. This is the graph of f of x equals 2 to the power x, and this is the line y equals to x. If you reflect the graph of f of x equals 2 to the power x about the line y equals to x, you get the graph of the inverse function, which is y equals log x to the base 2. So y equals log x to the base 2 is the inverse function of f of x equals 2 to the power x. The question, how to graph this function? Look to the question here in this example. He says graph f of x equals 2 to the power x and log x to the base 2 in the same rectangular coordinate system. The same rectangular coordinate system, yani like this. So this is the graph of f of x equals 2 to the power x, and this is the graph of f of g of x equals log x to the base 2. What is the relation between the two graphs? Since g is the inverse function of f, then if you interchange x and y, you go from f to g. So to graph g, you start by graphing f of x equals 2 to the power x. You make a table of coordinates. This table is the table of coordinates for the function f of x. And then you change y, you put it x. The same values of y, you put it as values of x. You put them as values of x. And the values of x, you put them as values of y. So log 1 over 4 to the base 2 would be negative 2. Log half to the base 2 would be negative 1. Log 1 to the base 2 would be 0, and so on. And then you put these points on the graph, on the coordinates here, and sketch the graph of g of x. So this is how we graph g of x from the graph of f of x. We find table of coordinates for the exponential function, and then we interchange x and y to get a table of coordinates for g of x, and then we sketch the graph of g of x. Now, an important question, is this the only way? Do we have another way to graph y equals log x to the base 2? And the answer is yes. You can graph this function, or you can make a table of coordinates of this function using the fact that this logarithmic form is equivalent to this exponential form. So these two are equivalent. So you make table of coordinates x and y. And here it is easier to choose values for y. So you replace y by the important values negative 1, 0, and 1. And then 2 to the power negative 1 would be half. 2 to the power 0 would be 1. 2 to the power 1 would be 2. So you have the points half, this is half, and negative 1. This is this point. 1 and 0, this is this point. 2 and 1, this is this point. And you sketch the graph of y equals log x to the base 2. Whenever the base is greater than 1, the graph will be always like this. The graph of the logarithmic function, will be always increasing like this. The graph of y equals 2 to the power x has a horizontal asymptote y equals to 0. The graph of log x to the base 2 would have a vertical asymptote with equation x equals to 0. So x equals to 0 would be the vertical asymptote. This is an exercise. Sketch the graph of f of x equals 3 of x, 3 to the power x, and log x to the base 3. you should know that these two functions are inverses of each other. So in fact, g of x is f inverse of x. And that's why we make a table of coordinates of f of x. You can choose only 3 values, as we mentioned, -1, 0, 1, and then you switch, you reverse the coordinates, you interchange. So you write the values of x as values of y, and the values of y as values of x, and then you sketch the graph. So let us do it here. Let us graph both functions. So this is -1, 0, and 1. And here 1, 2, 3. Now at 0, it is 1. At -1, it is 1 over 3. At 1, it is 3. So this is the graph of the exponential function y equals 3 to the power x. Now let us sketch the graph of the logarithmic function, this one. Now at -1, when x is 1, let us take when x is 1 over 3. I'll take these 3 values. When x is 1 over 3, so x is here, 1 over 3, y is -1, so at this point. When x is 1, y is 0, so this point. When x is 3, y is 1. So the graph would be like this. So this is the graph of log x to the base 3. And the line y equals to x is here. This is the line y equals to x. So the graph of y equals log x to the base 3 is the reflection of the graph of y equals 3 to the power x about the line y equals x. Okay. The same question, but here the base is half. If the base is half, then the graph of the exponential function will not be increasing. Okay, this is x and this is f of x. Let us make a table of coordinates of the first function. We choose the values -1, 0, 1. Half to the power -1 is 2. Half to the power 0 is 1. Half to the power 1 is half. Now the same table of coordinates, I change it. I reverse 2, 1/2 would be the x values. -1, 0, 1 would be the y values, because g of x is f inverse of x, because half to the power x, the inverse function of half to the power x is log x to the base half. So let us sketch the graph. Now for the exponential function, at -1, it is 2. At 0, it is 1. At 1, it is half. And the graph, if you remember, like this. This is the graph of y equals half to the power x. Now, what would be the graph of g of x, the logarithmic function? At 2, it is -1. At 1, it is 0. At half, it is 1. So the graph would be like this. Okay, this is the graph of log x to the base half. You will find again that this line, which is the line y equals to x, if you reflect the graph of y equals half to the power x about this line, you will get the graph of log x to the base half. Make sure that you understand that there is a horizontal asymptote and vertical asymptote. There is a horizontal asymptote for the exponential function. This is the line y equals to 0, and there is a vertical asymptote for the logarithmic function, which is the line x equals to 0. Okay, so now we know the graph of the logarithmic function in both cases. If b is greater than 1, if the base is greater than 1, then this is the graph of the exponential, and this is the graph of the logarithmic, and this is the vertical asymptote, and this is the horizontal asymptote. If the base is less than 1, and of course it's greater than 0, then the two functions are decreasing. And this is the graph of the exponential, and this is the graph of the logarithmic. These graphs are very important, and you must memorize them by heart. These are the characteristics of these graphs. Okay, what are the characteristics? We have the domain. What is the domain of the logarithmic? It is the range of the exponential, which is from 0 to infinity. The range of the logarithmic is the domain of the exponential, which is all real numbers. And you can see from the graph here, see the graph of log to the right of the x-axis, to the right of the y-axis. يعني الدومين of log only the positive numbers, only the positive numbers. But the range of log would be all real numbers. Okay, the 0.10, the 0.10 is an x, and the 0.10 is the x-intercept. Okay, the graph passes by the 0.10. Always the logarithmic function passes by the 0.10, while the exponential function passes by the 0.01. 0.1 is the y-intercept for the exponential. 1, 0 is the x-intercept for the logarithmic. Or you can say the x-intercept is 1. It's okay. Either you say the x-intercept is 1 or the x-intercept is the 0.10. If b is greater than 1, the logarithmic and the exponential are increasing. If b is less than 1, the logarithmic and the exponential are decreasing. Now, there is a vertical asymptote, which is the line x equals to 0. And the meaning of vertical asymptote, the graph approaches the vertical asymptote, but never touches the vertical asymptote. So these are the characteristics of the logarithmic functions. Now let us talk about transformations. If you remember, in 4.1, we mentioned the transformations of the exponential functions. Here, let us talk about the transformations of logarithmic functions. Similarly, if you add c to the y plus c upward, minus c downward, plus c, if you add plus c and minus c to x, not to y, you will go plus c, you will go left, minus c, you will go right. If you multiply the y by negative, then there is a reflection about the x-axis. If you multiply x by negative, then there is a reflection about the y-axis. If you multiply y by c, there is a stretching and shrinking vertically, vertical stretching and shrinking. If c is greater than 1, it would be stretching. If c is less than 1, it would be shrinking. And if you multiply x by c, we will have horizontally stretching or shrinking. Okay, horizontal stretching or shrinking. This is an example. This is, we have f of x log x to the base 2, and here log x minus 1 to the base 2. What happened? This 1 unit, you go here, you here, similarly. So 1 unit to the right. So it is the same graph, but 1 unit to the right. Now, if you translate the graph 1 unit to the right, what happens? The vertical asymptote changes. The vertical asymptote of f of x, x equals to 0. If you move it 1 unit to the right, the new vertical asymptote would be x equals to 1. Also, the x-intercept 1 will move to 2 لأنه you change it 1 unit to the right. So the red one will be the graph of g of x. So this is the translation. More examples about translations. Look here. This is the graph. The blue is the graph of log x to the base 4. If you add 3, you go 3 units up. the x-intercept 1, now 3 units up, okay? And the vertical asymptote here does not change. طيب, if you multiply log by a minus outside, then there is a reflection about the x-axis. So this is the graph. The blue is the graph of log x to the base 2. You reflect the graph about the x-axis, so the x-intercept will not change, the vertical asymptote will not change, but the red graph will be the reflection about the x-axis of the blue one. Now, if you multiply x by negative, not the y, the x from inside, there will be a reflection about the y-axis. So the blue graph is the graph of f of x. You reflect this about the y-axis, you get the red one, which is the graph of log negative x to the base 2. The vertical asymptote is not going to change. The x-intercept will change from 1 to negative 1. So these are examples about the transformations. Let us now try to solve some questions. مثلا, here, these questions are old. I think we can solve it easily. You can do it by yourself. Evaluate. We did evaluate last time. For example, what is log 16 4? You think 4 to the power what equals 16? 4 to the power 2 equals 16. So the answer is 2. So you can do all of these questions, 21, 29, 34. All are evaluate, 41. If you remember, this is a property, 8 log 19 to the base 8. The answer would be 19. Everything cancels. We studied this last time. Let us now solve question 43. Okay, question 43 says graph f of x equals 4 to the power x and log x to the power 4 in the same rectangular coordinate system. We just did it. Okay, we just did something similar. So please solve this question. It's similar to this one, 2 to the power x log x to the base 2. Here 3 to the power x log x to the base 3. Here 4 to the power x and log x to the base 4. It is exactly the same. Okay, only the table of coordinates will be different. Okay, so this is question 43. 47. Let us now solve these questions. 47, 48, 49, 50, and 51 and 52. These 6 graphs are given. This would be the last thing we talk about today. These 6 graphs are given. And here we have 6 functions. And the question, the graph of a logarithmic function is given. Select the function for each graph. Okay, so write, let us start by the first function, f of x equals log x to the base 3. Is this the graph of log x to the base 3? No. Is it this one? No. Is it this one? No. Is it this one? No. We know the graph of log x to the base 3. We just graphed it. The log x to the base 3 is this one. This is the graph of log x to the base 3. x-intercept is 1. Well, vertical asymptote x equals to 0. 3 is greater than 1. So this is the graph of y equals log x to the base 3. Okay. What about log x minus 1 to the base 3? This is 1 unit where?
To the
1
right.
unit to the right. To the right. So we need to take, we need to shift this graph 1 unit to the right. Is it this one? If we shift it 1 unit to the right, is it this one? Yes. It is. So this is the graph of log x minus 1 to the base 3. 1 will go to 2, will vertical asymptote will go to, it will be x equals to 1. Okay, good. What about h of x? log x 3 minus 1. هنا ال1 from y, يعني 1 unit down. Okay, so we need to take the graph, this graph in 52, we need to take it 1 unit down. Okay, فالvertical asymptote will not change. I will have this point اللي هي 1 ونيجاتيف 1. فwhere is the graph of h of x? h of x had this one. This is the graph of y equals log x3 minus 1, because ال1 هنا 1 unit down. Okay, 1 unit down. But this is the graph of log x3 minus 1. طيب what about negative log x3? How we need to reflect the graph about the x-axis. So we need to reflect this graph, اللي هو 52, about the x-axis. So the graph will be like this if you reflect about the x-axis. So where is it? Which one? It is 50. So this is the graph of negative log x to the base 3. طيب what about negative from inside? Here we will reflect the graph about the y-axis, which is 48. So this is log negative x to the base 3. What about this one? Here we have two transformations. We reflect the graph about the x-axis, which is this one, which is 50, and then we take it 1 unit up. So if you take this graph 50 and 50, if you take it 1 unit up, then this one will come here and you will get question 47. So 47 is capital H of x 1 minus log x to the base 3. I stop here and I open the floor for your questions. Please, if you have a question,